Welcome to Skill Session. This is our second video in our series about UML diagrams. Today we're going to talk about UML component diagrams. And a component diagram is much like the context diagram that we covered in the last video. The only difference is that where the context diagram looks outside of the application to see what is it that we need to connect to, what systems surround us, this one looks inside of the application and try to chop it up into useful building blocks to get a helicopter view of what the application is going to look like. No details or anything, just a complete overview of what separate components might make up this application. This can help us to do a bunch of things. It can help us to see what technologies we're working with. It can help us to see what systems might be in place. And we might even take a look at it afterwards and say, well, maybe this one we could use an external system for. So maybe we need a chat feature, and instead of building it, we're using an external one. And then we just move that building block from our component diagram over into our context diagram. Of course, there might be some overlap as well, because when you're using an external system, you'll still need to build an integration with that system, and that integration might be a building block in and of itself in your component diagram. So without any further ado, let's dive right into it and try building one in diagrams.net. So we still have this context diagram open. And that's great because we have these two tabs here, and we can just go back to the first one and say start once again. Create new diagram, and this time we want to create a component diagram, and I still don't think that's actually a thing in here. Is it? Well, it is. There it is. That's a component diagram right there. So component, library, component, hit save. And we have a component diagram right here. Now, this is supposed to show you how we have some larger blocks that contain multiple things inside them. So this is like components of components. Generally, when you build software models like this, a component is either built as this kind of block here, where you have a square with these two squares out on the side, and then the name of the component inside of it. Or you just have a square with the name of the component inside of it, and then a tiny little symbol up here saying that it's a component. That symbol is then again a square with two squares on the side of it. So that's how you recognize a component or a component diagram. Now, this is a kind of a simplified example, and it goes a bit in a different direction than what I want right now. So sure, we could build these blocks, but we're going for a simpler example. So if you're building something more complicated, sure, do that. But that's not what we're aiming for right here. And there is a couple of components to a component diagram. And the primary one is this one right here. So let's just remove everything that we don't need. And then we have a couple of examples of components here. So we're building that library system, right? And that means that we need to have some kind of a system where we can just keep track of all the books that, well, maybe not all the books that exist, but pretty near, right? So we need a books system. Maybe that's something we get from that external system that we saw in the previous video, but it also might be something that we need internally. I don't know. So other than that, we need some kind of a user system. Even if we have a login system that's external, we still need to know who the users are so we can send them an invoice, right? Which means that we probably also need some kind of an invoicing system. Not so much to make the invoices, because we have an external system for that, but more to just keep track of who we already sent an invoice to, and just to get that overview inside of our own application. And then, of course, we need a lending system to keep track of who has lent which book. And then we need a warehousing system to make sure that each of our physical locales have a way to see if the book is actually present at their warehouse or at their physical library. So a warehousing component might be useful for that. Now, when we build a component diagram, we use these strange arrows here, and I'll just create another arrow here that connects to it. and I'll give it the appropriate arrowhead for this. And that's going to be this open one here. So generally think of it this way. A component can do two different things. It can provide something for you, or it can require something from you. So I think of these circles and half circles as hands, right? I need something. Give me something. This is my open hand, and that's how I think of this. That this books component is now going to need something from the user component. Now, the user component then hands it over, saying, "Here you go. Here it is." So I envision it like these two hands. This hand is trying to give something to this hand that's trying to receive it, right? So that's my way of remembering it. Anyways, might be helpful to you, might not be. So that's what you do here. Our books require something from the user. That would absolutely be nonsense. It doesn't. But so maybe there isn't actually any relationship between the books and the users, because what we need is the physical books that are in the warehouse. So let's take a look at how we could connect some of these things. First of all, we could say that the invoice is something that has to do with the user, right? You cannot send an invoice to no one. You have to send it to someone. So the invoices don't work unless there's users. So the invoice requires a user. There we go. Let me just make it a little bit prettier. Then what else do we have? Do the users require an invoice? No, they don't. Now, each of these connectors, you could build them out as their own thing. And you typically do that. You know, a component diagram can be seen in two different ways, really. You can have a diagram where you're just showing every single component and what it has to offer and what you could get from it. So the way that would look would be like to say books in here. Well, it has these different things that it can require, and then it has these different things that you can require from it. That was not the right arrowhead, I don't think. Nope. There it is. So you can build a component diagram like that, and then just type next to it what exactly is it that we want from that we can require here. So it can require authors, for instance. It can require publishers. Or it can require, well, an actual book. So what can you get from it then? Well, I think in this particular example, it's actually pretty much the same things. This is just something that's going to help you get an overview. So I'll just say that it's the same things right here. So this, what we have right here, this part, this is one type of component diagram. This is a diagram that just shows what a component is capable of. What abilities does it have? Well, the other type is the part where we put our components together and figure out what exactly is it then that they use to interact with each other. So if this is not used in the context of this diagram, then there's no reason to show it. And so instead we just go ahead and we build these connections right here, and then we can type right next to it, user for invoice. And that means that the next thing here is that the warehouse needs books. So it needs something, right? It requires something. So it's going to have that open hand, and then it's going to have that close hand for a book, because that's what it needs, really. So let's drag this up here, make it an open-ended one. And that way we can see that the warehouse actually requires some books. What else does that need? Well, not necessarily anything. Well, maybe it needs to know about lending, but that depends on how you're going to set up your whole library system. So next up, we have lending. So lending requires that there is a user. You cannot lend something out to no one. And it also requires that there is a book to be lent. And then the question becomes, and that's why it's so important to build these diagrams up front, is this a physical book from the warehouse, or is this just any book that exists? And I would argue that right here we're talking about a book from a warehouse, because this is just a list of every book that exists, as a concept. So if I have this book right here, right? Sorry, this is a Danish book, but the idea is that this would be a book in the books. But if I have multiple of them, then that wouldn't be multiple books in this books component. That would be two different copies of that book that exist in the warehouse. And that's why lending connects to the warehouse and not to the books. So let's drag this down here, connect the right arrowhead, and then do the same for user up here. There we go. So now we have some idea that lending requires a user to lend something, and what they're lending is something from a warehouse, which could technically be something that's not a book as well. So I suppose that makes a lot of sense. So this is not by any means complete, but I hope it gives you enough of an overview of how to build a component diagram. And of course you can type out here next to these arrowheads if you have that other type of component diagram where you're listing out the full list of things you can require from it, or that it can require, then you can type that right next to them right here, so you can see how those two diagrams fit together. When you have components like this, when you start building your software project, you could actually just, even when you're going into building class diagrams next, you can start adding out responsibilities to the people on your team and say, okay, so you're going to build the user component. Please make a drawing of that. You can make a drawing of the invoicing component. You can make a drawing of the warehouse component, and so on. So you can start dividing responsibilities and then start building your own knowledge bases so everyone's not working on the same thing. You're ready to do that already at this point. But when we talk about dividing areas of expertise, there is a typical division of that in software development, right? When we're talking about web development, we'll always have a front end, a back end, and a data layer, right? So it could be your presentation layer, your domain layer, and your persistence layer, or whatever it is, but you'd want to have those things. And it would make perfect sense to actually build a component diagram that shows that. So maybe you'd want to build it in a separate diagram, but let me just show you how we could use this exact same structure in order to build something like that. So let's say that we're building this application in a Java backend. And we're going to have an Angular front end. And then we're going to add it all to a Linux server. So those are the internal components that make up our application. Sorry, we need a database. Let's say it's a MySQL database. Then all of these applications are going to be hosted on the same Linux server. They're going to require a Linux server in order to run, basically. This database, it doesn't care if there is a Java backend, so it doesn't require that. It's the other way around. The Java backend is going to require this database to exist. So let's shuffle that around. On the other hand, the Java application doesn't care if there is a front end on it. It can run through APIs or through whatever. So it's gonna put something forth that the Angular front end is going to require. So I'll change this arrowhead right here. And all of these are going to require something from the server. So the server is going to provide a place for all of these other things to run, right? So there we go. This would be a component diagram showing the infrastructure of the application. And this is something that we could use to talk about operations and how to actually operate and run this application. You could add other things to it if you're using different DNS servers or some cloud provider or whatever it is. You could add more things to it, but I hope this gives you an idea of how, once again, to use this. One last thing that I want to say about component diagrams is sometimes this goes both ways, and sometimes you can have multiple dependencies here to say, well, this Angular frontend actually depends on both the Java backend and on something else, and it goes for topical components as well. That you can have multiple, and you can have if let's say the Java backend actually did depend on the Angular frontend, that wouldn't make any sense. But if it did, then then you would have the same arrows just reversed right next to it. Well, maybe that wouldn't make sense. That's entirely up to you. It does have something to provide, right? It is a way for data to get into the backend. But one thing that's important to remember about all kinds of UML diagrams is that they're a useful tool to convey a message, but they're never complete or 100% accurate. So just get them as accurate as you possibly can. You could, of course, expand on this by saying that, okay, so for my backend application, that's what's going to be the big part there here that's going to take up all of the work. So let's move this to the back and then say that we have a system here, right here. So maybe this is the actual Java backend. And we can take the text here and say that it's supposed to be on top. And then in here, this is our Java backend API. And it might be connected to something else in here, like a persistence component. If you're using a 3-layer architecture, right? Then you could have this front end, or you could actually call it your presentation layer. You could have your persistence layer, and you could have your domain layer. And you would put presentation, domain, and persistence like this in the application. And then, of course, persistence would be this, but your front end would connect to the presentation layer instead, somewhere over here. So something like that. I'm not going to drag everything nicely in this example. And then in here, these would connect to each other. And in the domain layer, you could then connect to all of these other components that we had before. So I hope that gives you a good overview of what a component diagram is, how it connects with the context diagram, so that you can really get an overview of what are the surrounding components and what are the internal components that make up this software. We're not going in any form of detail right now. We're just getting an idea of what the overall ideas of the application is, what we connect to, what we build it out of, what are the building blocks. This is something that's extremely useful internally for the development team later on, and in order to build better diagrams when we dive deeper. But it's also something that you can use for business people who are completely non-technical, and you can just show it to them and say, do we agree that this is, the software that you want us to build? And then go one step deeper after that. So it's a really, really helpful and useful tool. Now, there's two different ways that we can go from here. I would typically go into building a data model or an entity relationship diagram as the next thing, because I feel like that's the next logical step into dividing all of the data we're going to be working with. But if we're doing this in the context of learning UML, then entity relationships or entity relationship diagrams are not technically UML. In UML, it's a little bit more object-oriented, so you jump directly into a class diagram. And the reason is that many of the classes would just map directly to entities in your database, and you typically use an ORM to connect to your database, so you're maybe not really worried about what the database looks like anyway. I feel like that's jumping an important step, so I like to do both, but that's the way it's set up. So if you want to jump directly to class diagrams, you can do that with this video right here. And if you want to go through entity relationship diagrams first, the way I would do it, then you can do that right here. And that video is going to link you to the UML diagrams afterwards. See you over there.